if you keep here a flash drive, make sure you put it in a small kind of envelope with a name so that it doesn't get combined with or mixed up with other students' flash drives. Okay? Make sure a name or something is there.
Dr. May, you'll be in your office tomorrow, right?
Right, tomorrow.
I just bring it to you tomorrow.
Yeah. Okay, so we talked about this a little bit last class about your in the framework of the project, right? So in the project 4, you will really do this in Java, Linux, Java environment, right? So what is the context there? You are given, say, two users A and B. You have a file of user A which user B is trying to modify. User A initially has given the permission for user B to modify the file. So user B has opened the file using a file reader program and is writing the file. While the file is open and user B is writing it line by line, user A removes the write permission for user B. Right? So technically you shouldn't be expecting user B to still be able to write the file. But user B will be able to write the file because the file is still open. So the operating system checks whether user B can update the file only at the time of opening the file descriptor or file pointer. Once the file is open, the user can update the file any number of times until he closes the file. Right? So only when he closes the file and reopens the file, he won't be able to write the file because when you check for the permissions at that time, it would be removed for the user. Right? So what is the thing here? In the first case, when the user opens the file, when user A has given the permission for user B to write to the file, right? User B opens the file and writes the file, right? So at the time of opening the file, user B has the permission, so that's a time to check, a time of check, and at the time of really writing to the file, the operating system doesn't check whether the user has the right permission because it already checked and it remembers that okay, the user B has the right permission. So at the time of writing, the time to use, it doesn't really check. At time of use, it doesn't really check whether the user has the right permission because it already checked and it assumes that permission still exists. Okay? But if the time gap between the two, between the time of check and time of use is really long, then something like what we are discussing will happen, right? Because if user B opened the file say 10 hours ago and then user A changes the permissions for user B that he can no longer access the file, but if user B is allowed to keep the file open and keep on writing and not close the file, then user B can keep on writing the file even though user A has removed the right permission. Because as I said, you check for the permissions only once, then you can write any number of times you want to a file until you close the file. Okay? So the time gap between the time of check and time of use is very long, and that's the vulnerability. You should not let the time gap should be longer. Which means if you want to have multiple writes like this, it's better to check every time or every certain number of times whether the user has right permission. You don't just check once and just take it for granted that the user has the right permission whatever times you want to write. Right? This is clear? So this is the actual project, and you do it in a Java. You can do it on a C also. I think I've given the code for C++ too, at least for this project. One of your forthcoming projects, you may want to do it in Java, the source code and a license. Okay. So is that clear? So now we are going to look at more from a Unix perspective. Yeah, so I already did the project 2 on this Unix permissions and things like that, right? There are two things associated with a process. When you run a process, write a program.
Question. Like for that, when the okay, so user, let's say user 2 still has the file open, and to start another, like another secure shell session or something, can he still access the file?
User who has the file, user B has the file open.
Right.
Right.
So, and user A already changed the permission.
Right.
So, if user 2 opens another secure shell session, for example, can he still?
If he tries to open the file again,
On another session.
On another
but
session.
he hasn't opened in the first session.
right, he can do the updates on the first session, because the first session, as I said, is the permissions check on the first time he opens the session or opens the file. He can update any number of times. But if you open a new secure shell or new session and try to open the file on another terminal, you will not be able to do that. Okay, that's a good question. Try that. It's like in this project, you can run this program on 2 terminals, right? So in one terminal you run this, and you can keep updating it. After user A has reset the permission, open another terminal and try to run this program again. You will not be able to update the file. Okay? Alright, so in a unique scenario, each process at any time has its 2 IDs. What is called the UID is also called the real user ID, and the effective user ID called the EUID. Okay. Remember, as I said, you write a program as the developer or the owner of the program, but you may want your program to be run by several users, right? So you develop your process program, and the program can be executed as a process by several users, right? The same thing like a password program. The password program is developed by the root or the administrator, and any user can run the program. Okay. Now, so like that, let's say there are 2 users. User X and user Y. And there's a process P, okay, that is really developed by or owned by user X. So program P is developed by user X, and he's the owner of the process, and the program is run. Now, when user Y is trying to run that program, right, as a process, what are the permissions that user Y has, right? Now, typically, if when a program is run as a process, the things that someone can do using that process depends on what is the effective user ID of that process. As I said, each process has 2 things. The UID is basically the ID of the owner of the program. The user ID of the owner of the program. The effective UID is the user ID of the user running the program. So, in this scenario, if user X has developed program P and user Y is running it, the effective user ID of that process is actually what? Corresponding to user Y, right? Like, the password program is developed by the root, but if you are running that program, then the effective user ID of the password program is your user ID, who is running that program. So the operating system always checks if you are trying to do certain things on the system using that program P. The operating system checks whether the effective user ID can do that. Okay. So for example, if I develop a program P and you are running my program, right? When you want to do certain things through my program on the system, the operating system checks whether the effective user ID of that program can do those things, right? Typically, if you run my program, the effective user ID of my program is going to be your user ID, right? So, which means it checks whether you could do certain things. If you want to update a file, it checks whether you could update the file, right? And how it does that? It checks whether the effective user ID of the program can have the right permissions, or what are the permissions you are trying to do, okay? So, for example, if you are trying to use the password program and say change the password file, okay, it checks whether the effect user ID of the password program can change the password file. Okay? If the effect user ID of the program is a regular user who cannot access the password file, you cannot access the password file. Right? So that's why what we do, the system administrators, what they do, make the password program as what is called a set UID program. When you make this program as a set UID program, right, the effect user ID of a program whose set UID bit is set is always the user ID of the owner of the program, right? So if this process P is a set UID process, when user Y is running it, the effect user ID of the process is what?
Say it again, Dr. Mayor.
If I set this process P as a set UID program and user Y is running it, what is the effect user ID of that process? User X. Because user X is the owner of the program, right? If you do not set the set UID bit, that's a general typical scenario, right? The typical scenario is user X has developed this process, so user X is the owner of this process and user Y is simply running it. In that scenario, the effect user ID of this process is Y, because user Y is running it and whoever is running it, his user ID is effect user ID. So when Y is trying to do certain things through that process, the operating system checks whether the effect user ID of the process at runtime can do those things. So if user Y is trying to change a file, the operating system checks whether the effect user ID of the process, which will be Y, can change the file. Right?
But user X is the owner, right?
When user X is the owner. And the set UID bit is not set. But if user X says, let me set the set user ID bit on this process P, it basically means whoever runs the program, like user Y running the program now, his privileges are escalated, which means the effect user ID of the process becomes the owner of the program. So anyone can run that process P, developed by or owned by X. The effect user ID of the process is X. So which means if you want to change something through that process P, it checks whether the effect user ID, which is X, means the owner of the process, can change the file. So that is the case with the password program. Why? Because the password program is a set UID program developed by the root or owned by the root, right? So the password program's owner is the root, and if a regular user tries to run the password program, right, but since it is a set UID program, okay, when some regular user is running the process, the password program or the process, what is the effective user ID of that process? The effective user ID of that process is?
Like X?
The root.
Right, the
because
root
it's a set UID program, right? So which means even though you are running as a regular user, you get the privileges of the root. So through the password program, if you want to change the password of yourself, because that's why I said last class, even though you set it as set UID program, you write the program carefully so that you cannot change anyone else's password. You can change only your own password. Okay? But either way, still, if you want to change your own password, you should be able to update the password file. Right? So once you set this password program as a set UID program, when a regular user runs it, the effect user ID of the process is still the root or the owner of the program. So if the regular user wants to change anything through the password program, he can change the file, contents of the file. Of course, it's only his own password.
But if it's not set, he just
If
runs
it's
it.
not set, if it's not a set UID program, then when a regular user runs the password program, he cannot do anything as a root. He can do only what he can do as a regular user through that process. That's what is typical scenario. Very rarely programs are given a set UID permission because it's a risky thing. Someone can misuse this. Okay, like we saw the buffer overflow attack last time could be launched on a set UID process, because if someone can pass a shell script as an argument to the buffer, they can really run the script as a root if this is a set UID program. Okay, so that's why we don't normally give a set UID program for all processes.
It's not the same thing as when we run an administration like we did on that project. You know, I went to C prompt and you said, click, make a right click, run it as administrator.
Run as administrator. Yeah, but there you really want to change. You could run. That's another software security principle in the sense that you may have both permissions. You may have the administrator permission. You may have the regular user permission. So one principle of security is if you want to accomplish certain tasks, the operating system should assign you the minimum level of permission. So if you can complete the task as a regular user, you should not be elevated as an administrator. You should be elevated to an administrator level only if you need the administrator level privileges to do certain things. So user may have different roles, so that's a role-based access control model. The user can take any number of roles, but if to do a certain thing, he should be assigned the minimum level of permission. Okay, he should not be given more than the minimum number of permissions. So in that case, to do all those firewall things, you need to run the DOS window as an administrator. You cannot do it as a regular user. All the other scenarios, you run it as a regular user. Okay, so that's why you do that. Okay. So is this clear? What is the difference between an effect user ID and the regular user ID? The regular user ID is really the real user ID is the ID of the owner of the process or whoever developed the program. But the effect user ID is what is normally used to check if someone can do anything to that program. So if I run the program at runtime, if I try to do certain thing, the operating system checks whether the effect user ID of the process can do that. Okay? So typically, if it is not a set UID process, the effect user ID is the ID or user ID of the user who runs the program, right? But if the set user ID is set, then the effect user ID is the user ID of the owner of the process. So if the process is owned by the root, a regular user runs the process. So set user UID bit is set, then the effect user ID is the root. Okay? Is that clear? Now, there are several system calls. Probably you'll know and see Unix background. If you want to really change the contents of the file or open and read the file Unix background context, you have to launch some system calls. So this open function is like a system call to open a file and read the contents of the file. Similarly, the access function is also really access a file. It's also a system call. Now, certain functions, the functions kind of check for permissions is kind of slightly different. The open function opens a file using the effect user ID of the calling process, which means when you run a program and through that program, if you want to open a file and read the contents of the file, the open function checks if the effect user ID of the process at the runtime can really open the file. Okay? So if you run, say, program P and it is not a setuid program, then you run it as user Y, then the effective user ID of the process is user Y because it is not a setuid program. Okay? Then if you try to open the file through the process P, at the runtime it will check whether user Y has permission to open the file because the effective user ID is user Y. Whereas the access function checks whether the real user has permissions to access specified file. Okay? Which means again the same scenario, the real user ID is still what? User Y. Who runs this program is also run by user Y. It makes sense if, okay, let me change it a little bit. If you make it a set user ID program, right? If you make the set user ID program, then if you use the open function, the open function checks whether the effect user ID has the read permission. If you made it as a set UID program, but still if you use the access function, it still checks on the real user ID. The real user ID is still Y because Y is whom running the program, right? So if it depends on the function. Okay, so the access function always checks. If someone wants to access a file, it checks based on the real user ID. So if user Y is running the process, and through the process he is using an access function to check whether to access the file, the access function checks whether the real user running the program has the access permissions. Whereas if you want to use the open function to open a file and read the file, if the process is a setuid program, it checks only based on the effective user ID, which is in this case the owner of the process. So it doesn't really, the open function doesn't really check whether the real user can open the file. It checks whether the effective user ID can open the file. Whereas the access function checks whether the real user can access the file, even though the program may be a setuid program. So it makes really sense to just use the access function, right? But the access function probably cannot do everything that you can do with an open function. So each function has its own features, right? So if you really want to open a file and read the file, you may want to use the open function, okay? But the access function really checks for you whether the real user ID has access to the file. So what you should do, it makes sense from what I just discussed, to first check whether the real user has the access permissions on the file, and then use the open function to read the contents of the file. So as I said, if you use the access function, even though this may be a setuid program, right? When a regular user runs this program, its privileges are escalated. The effective user ID is the ID of the owner of the program, which could be the root. But when you try to use the access function to check whether the regular user has access to the file, in this case it is a read permission, you can check like that. ROK means whether the user running the program, the real user, has the read permission on the file. So it's going to return 0 if he has the permission. It's going to return non-zero value if he does not have the read permission. That's how Unix works. Okay? So 0 is always considered a success, and any non-zero value is considered a failure. So if the user doesn't have the read permission, it's going to return non-zero value. So whatever it returns is not equal to 0, then you can say cannot access the file and exit from the program. If it's going to return 0, it means the user has the read permission on the file, even as a regular user. See, the access function, as I said, checks based on the real user ID. So this may be a setuid program, but if user Y is running it, it will check whether user Y has read permission on the file. It may be owned by user X, who is the super user or the root. Okay? So now after we check whether the real user has the access permission, you go and open the file. Alright? So you open the file, but now, as I said, the open function also checks for the permissions. But the open function checks what? Whether the effective user has the permission, right? So the open function checks whether the effective user has the read permission. And the effective user is the root, or the whoever wrote this program, right? So of course the effective user is going to have the read permission, right? So since you already checked whether the real user running the program has the read permission, it is okay now to call the open function to open the file and read the contents of the file, because you already checked if the real user has the permission. If he doesn't have, you would have exited from the program. So after you do this check, you come here and open the file. But as I said, open function works based on the effective user ID, right? So it checks whether the owner of the program has the. So when you're running as a regular user, the effective user ID becomes the real user, becomes the owner's ID, because it's a setuid program. So this is what it does. It opens the file and then reads the file and copies them to a buffer and prints the contents of the file. So now we have to analyze what's the vulnerability with this program. What could someone do with this program to kind of launch what is called the stock tow attack, a time of check to time of use attack?
Not changing the time. What was the question?
You understood this program, right? So what is the vulnerability with this? that someone can exploit to launch this attack. Time of check to time of use. Where do you really check for the permission here?
In access.
The access function. And where do you use it? In the open function. Because you checked in the access function and you did not exit, you could continue, right? Only when you could continue, you could read the file, right? So which means if you could come to this level and open the file, it means you already checked for the access permission, it is you have the access and that's why you come here, right?
So they tamper with the access capabilities?
You use the access function to check for permission, you use the open function to use that permission, really. But you see there's a small time gap, right? It's a sequential program. So after you do this if block, you come here and do the rest of the code, right? There may be a very small time gap. During the time gap, someone can run certain things in the background. Okay? So what someone can do? Remember we talked about symbolic link before? So what's a symbolic link?
You can link to a file that you don't have access to.
Not always, but that could be misused. But we normally link a different file which you really want to store in a different location. If you change it there, you can access it from here and things like that, right? But as you say, yes, you can link your file and try to see, you may not have access to the file, but you may want to misuse it. And that's what we're trying to do now.
Dr. May,
Yes.
is it too much to ask you to explain it again? I don't think I fully got it.
Okay. You understood the difference between setting the set UID bit on a process and not setting it, okay? When you do not have a set user ID bit set, let's say process P is owned by user X, but user Y is running the process, the effective user ID of the process is Y because typically when this is not a set user ID process, whoever runs it, his user ID is the effective user ID. So you check for all permissions to do certain things based on the effective user ID. So if as a user Y, he cannot do certain things, he cannot do. But once you set it as a set UID process, like the parser program is a set UID process, the effective user ID of the process is always the owner of the process, whoever runs it. Whoever be the regular user who runs it, the effective user ID is the owner of the process. So like the parser program, when you run it, the effective user ID of the parser program is the root. When somebody else runs it, it's the root. So whoever runs it, their privilege is escalated or elevated, so they can access the password file and change the contents of the password file. Okay? So that is what about the difference between setting up the set UID bit and not setting it. Now we have a scenario where we have two of the system calls, open and access. Now let's say still there is a set UID bit of this process P is set, and in this process P, like in this program, you have two functions, the open function, the access function. Even if, like this, if the set UID bit of the process is set, if you have an access function, the access function always checks if the real user ID of the user who is running the program has the permission to do certain things, whatever is asking for. So for example here, the real user, which may be a regular user like you, trying to read the file, right? So the access function checks if the real user, say user Y, has the read permission of the file. Even though it may be a set UID program, it checks based on the real user ID. Whereas the open function checks based on the effective user ID. So it really makes sense if this process is a set UID process, then the open function always goes with what the owner of the process can do. Right? So in this case, after you make sure that the real user has the read permissions on the file, you come after that and you really open the file. So you open the file as the root or the administrator or owner of this process, right? So you run this set user ID process. In this block, you check the permission, whether the real user has the permission. Once you make sure the real user has the read permission, you come back and open the file. But the open function, as I said, works based on effect user ID. So it checks whether the effect user ID can read the file. And since at this point, since you're checking based on open the effect user ID and this is set user ID process, the effect user ID is the root, and the root can read the file, so you can open the file and start reading it. Is that clear?
Thank you.
So go back and in the following slide I have a description too. You can read it in this one also. So now, how can someone misuse it? Yes.
Instead of like using the root access to a file that only root has access to, using the file that they already have access to.
Can you repeat it?
They have access to a file, they can open the file, so then they use that program to set a symbol between that file and the file they can't.
Not really. You have to run, or you have some idea of it, but you don't run in two different files. You can use only one file. I'll tell you how to do that. You have to run another. Let me tell you how to do that. I think it's not exactly what you are doing. Okay. Okay. Let's say see here the objective is to read some file, right? Let's say the file that you want to read is named readme.txt or something. Okay? So this is the file that the regular user or the real user Y wants to read. At the time of this line of code, okay, using access function, it checks based on the real user ID, right? So the real user ID can ask if he has the read permission on the readme.txt file.
What did they say about regular?
Readme.txt, that's the name.
No, saying at the top.
Real or regular
Okay.
user. Okay? So if the regular user can, say user Y has the read permission on the readme.txt file, this test will pass, right? Isn't it? Now, on the background, this is one program running. On the background, or you open another terminal, and the user Y